Alright, so I want to find all roots of f of x equals x to the fourth minus 6x to the third plus 28x squared minus 18x plus 75 given 3 minus 4i is a 0. Since I know that 3 minus 4i is a 0, then I can use synthetic division to break this down by dividing by 3 minus 4i, right? So once I break it down, that'll give me x cubed. Then I'll be able to use 3 plus 4i, which is another 0, to break it down to x squared, solve the quadratic, right? So starting with 3 minus 4i and all of my coefficients. So I'm going to have 1, negative 6, 28, negative 18, and 75. And it's going to look funky, but it works the same exact way. So I'm going to bring the 1 down and multiply 3 minus 4i times 1 gives me 3 minus 4i, and add. Negative 6 plus 3 gives me negative 3, and 0 plus negative 4i gives me negative 4i, and multiply. 3 minus 4i times negative 3 minus 4i. I'm going to come over here to the side and multiply these together real quick. 3 minus 4i times negative 3 minus 4i. Just distributing, I get negative 9 minus 12i plus 12i plus 16i squared. My 12i's cancel out. I get negative 9 minus 16, which gives me negative 25. So I'll put the negative 25 in here and add. 28 plus negative 25 gives me 3, and multiply. 3 minus 4i times 3 gives me 9 minus 12i, and add. Negative 18 plus 9 is negative 9 minus 12i. Go ahead and multiply. 3 minus 4i times negative 9 minus 12i. I get negative 27 minus 36i plus 36i plus 48i squared. 36's cancel out. I get negative 27 minus 48, which is negative 75. Put in my negative 75. 75 plus negative 75 is 0, which it should be because we already knew it was a root. Okay? All right, so I had x to the fourth. This broke me down to x to the third. It's ugly. I'm not going to work with that. I'm going to break it down again to a quadratic. Since 3 minus 4i is a root, I know that 3 plus 4i is also a root. So I'm going to go ahead, set up synthetic division again, but this time using 3 plus 4i. And I'm going to use what I have, what is remaining. So I'm going to put 1, negative 3 minus 4i, 3, and negative 9 minus 12i. And use synthetic division again. Bring down my 1 and multiply. I get 3 plus 4i, and add. This cancels out to 0. Multiply, I get 0. Add, I get 3. Multiply, I get 9 plus 12i, which again gives me 0. Right? Which it should, because this is a root, so I should get a remainder of 0. I started with x to the fourth. Synthetic division once with a root gave me x to the third. One more time with a root gives me x squared. So I end up with x squared plus 0x plus 3. This is a quadratic that I can solve. I could go the long way and do quadratic formula, or since I don't have a middle term, I can just set it equal to 0. Subtract 3 from both sides. I get x squared equals negative 3. Take the square root of both sides. I get x equals plus or minus the square root of negative 3, which is plus or minus I square roots of 3. Right? It's imaginary. So my final answer, all of the roots are 3 minus 4i, my given root, 3 plus 4i, its conjugate, and then I have positive I square roots of 3 and negative I square roots of 3. Right? And again, I started with a polynomial raised to the fourth power, so I end up having a total of 4 roots.